Hello all, welcome to online lecture series on Laplace transforms. This is lecture number 18. Let us continue to work on second shift property. Before that, I'll just again give the definition of unit step function just for the sake of recalling. Unit step function is defined as u of t minus a is 0 for t less than a and 1 for t greater than or equals to a. And Laplace transform of unit step function is e power minus as by s. L of u of t minus a is e power minus as by s. And second shift theorem for Laplace transforms is given by this. I'll just read out the another form of second shift theorem because we use this form of theorem for our problems in this lecture. Laplace transform of f of t minus a into u of t minus a is e power minus as into Laplace transform of f of t. Here u of t minus a is unit step function. Okay. So now let us move to solve some problems using this unit step function and second shift theorem. Express the following function in terms of unit step function and hence find its Laplace transform. The function is given as f of t is equals to 0 for 0 less than t less than 1, t minus 1 for 1 less than t less than 2 and 1 for t greater than 2. So we are asked to express f of t in terms of unit step function and also find its Laplace transform. The Laplace transform of f of t can be directly evaluated using definition, but there we need to evaluate three integrals because we split the integral 0 to infinity as 0 to 1 plus 1 to 2 and 2 to infinity. So there are three integrals to be evaluated. But once we express the function in terms of unit step function, we can apply second shift property and evaluate its Laplace transform more easily. So now let us first look how can we express such function using unit step function. So first let us make a note of this point. Suppose if f of t is defined like this. In the interval AB, if it is f1 of t and in the interval BC, it is f2 of t and from c to infinity, it is f3 of t. Then we can express f of t like this. Watch carefully. F of t can be written as f1 of t, that is the first function, into u of t minus a minus u of t minus b, plus f2 of t into u of t minus b minus u of t minus c, plus f3 of t into u of t minus c. So observe how did we write as a unit step function. I'll explain you why we get f of t can be written like this. But first observe how we are expressing f of t. The first definition f1 of t into u of t minus a, the lower limit, minus u of t minus b, unit step function corresponding to upper limit, plus second definition f2 of t into u of t minus b minus u of t minus c, plus and the last definition from c to infinity, there we get plus f3 of t into u of t minus c. Okay. So let us see now why f of t is equals to this. So first let us take the case where a less than t less than b, that is in this first interval. Let us see what is f of t. If a is less than t, that is t greater than a, then by unit step function definition u of t minus a is 1. And what is u of t minus b and u of t minus c? Because t is less than b, u of t minus b is 0 and t less than b here, t less than b here and b is less than c. Therefore, t is also less than c. Therefore, u of t minus c is also 0. So now here, see here, u of t minus a is 1. This is 1. This is 0. This is 0. This is 0. U of t minus c is 0. So we have only f1 of t. So in the interval a less than t less than b, f of t is equals to f1 of t. Okay. So that is proved there. Now let us take the another interval b less than t less than c. Now see the second case. When b less than t less than c, that means what is relation between A and B? A less than T less than B. Therefore, A less than B and B less than T and T is less than C. So now let us write what is U of T minus A, what is U of T minus B and U of T minus C. Because T is greater than A, T is greater than A, therefore U of T minus A is 1. And T is greater than B, therefore U of T minus B is 1. But T is less than C, therefore U of T minus C is equals to 0. I am writing this from the definition of unit step function. Okay. Now substituting the unit step function values, U of T minus A is 1. This is 1 and this is also 1. This is also 1. U of T minus B is 1 and this is 0. U of T minus C is 0 and this is 0. So now the first term they become 0 because 1 minus 1 is 0. Second term is f2 of t into 1 minus 0, that is f2 of t plus 0. So in the second case we got f of t is equals to f2 of t. Now let us look third case. What is third case? If t is greater than c. If t greater than c, what is the relation between a, b and c? A less than b, b less than c. Therefore, A less than, B less than C and C is less than T. Now, what are the values of U of T minus A? Because T is greater than A, U of T minus A is 1, U of T minus B is 1 and U of T minus C is 1. Now, substitute here. This is 1, this is 1, this is 1, this is 1 and this is 1. So, this becomes 0. 1 minus 1, this becomes 0. 0. Even this function becomes 0 and this is f3 of t. Therefore, for t greater than c, that is in third case, f of t is equals to f3 of t. So, whenever f of t is defined like this, f1 of t in the interval a less than t less than b and f2 of t in the interval b less than t less than c and f3 of t for t greater than c, then f of t can be written as f of t is equals to f1 of t into u of t minus a minus u of t minus b plus f2 of t into u of t minus b minus u of t minus c plus f3 of t into u of t minus c. So now let us go back to our problem. In our problem, f of t is given as 0 in the interval 0 to 1, t minus 1 in the interval 1 to 2, 1 for t greater than 2. So our f1 of t is 0, a is 0, a is 0, b is 1, f2 of t is t minus 1, b and c is 2 here and f3 of t is 1. So we can express f of t as f of t is equals to, again same, I have written the same equation. Now let us substitute these values. f1 of t is 0. So f1 of t is 0. U of t minus a, the interval here is t minus 0 less than t less than 1. Therefore, u of t minus 0 minus u of t minus 1 plus f2 of t is t minus 1. T minus 1 into u of t minus 1 minus u of t minus 2 plus f3 of t is 1 into u of t minus 2. Okay. Now, the first term is 0 because 0 into anything is 0 plus second term is t minus 1 into u of t minus 1 minus t minus 1 into u of t minus 2 plus u of t minus 2. That is equals to t minus 1 into u of t minus 1. Here t minus 1 plus minus of t minus 1 plus 1. That is minus of t minus 2 into u of t minus 2. Now if you observe here, the last equation is of the form u of t minus a, f of t minus a into u of t minus a. Here also the second term is also f of t minus a into u of t minus a. So here we can apply second shift property to find Laplace transform of the function f of t. So f of t is expressed in terms of the unit step function u of t minus 1 and u of t minus 2. Therefore, f of t is now finally t minus 1 into u of t minus 1 minus t minus 2 into u of t minus 2. Now to find Laplace transform, we just apply Laplace transform on both sides. L of t minus 1 into u of t minus 1 minus t minus 2 into u of t minus 2. Separate the Laplace transform and apply second shift property. What does second shift property state? L of f of t minus a into u of t minus a is e power minus as into L of f of t. So here in the first case, a is 1 and f of t is t. T minus a is t minus 1. Therefore, f of t is t. And hence, by second shift theorem, this is e power minus a is 1. So, e power minus s into L of f of t. F of t is t here. And in the second case, we have t minus 2 u of t minus 2. Therefore, e power minus 2s into L of f of t. F of t is t here. So, what is L of t? Is 1 by s square. Therefore, this is e power minus s into 1 by s square minus e power minus 2s into 1 by s square. That is e power minus s minus e power minus 2s by s square. This is Laplace transform of f of t. So, here we express the given function f of t in terms of unit step function and we applied second shift property to derive the Laplace transform of that function. So, these are very important problems. So, do practice well. We'll see the similar type of function here. Using unit step function, find the Laplace transform. F of t is defined as sin t in the interval 0 to pi, sin 2t in the interval pi to 2 pi, sin 3t for t greater than 2 pi, that is from 2 pi to infinity. As in the previous problem, we express f of t in terms of unit step functions u of t minus 0, u of t minus pi and u of t minus 2 pi. So, we write f of t as f1 of t. What is f1 of t here? Sin t into u of t minus 0 minus u of t minus pi plus f2 of t is sin 2t into u of t minus pi. See the ends of the interval. U of t minus pi minus u of t minus 2 pi plus f3 of t. F3 of t is sin 3t into u of t minus 2 pi. So, if we multiply and we just simplify, we get sin t into u of t minus 0 plus sin 2t minus sin t into u of t minus pi plus sin 3t minus sin 2t into u of t minus 2 pi. Just rearranging the terms. Now, if we look here, you have 2 u of t minus 0 and here sin t can be written as sin t minus 0. T is t minus 0. So, there is no problem here. We can apply second shift property while deriving the Laplace transform. But look at the second term. Second term we have u of t minus pi here but we don't have t minus pi in these two terms. So, we need to write this in terms of t minus pi. Similarly, the case in third term also. We have u of t minus 2 pi here but we don't have t minus 2 pi terms here. So, we need to write in terms of t minus 2 pi. Because these are sine terms, we can express this as first term is same sin t into u of t minus 0. This is again the same equation as above. Now, look at the second term. Sin 2t minus sin t can be written as sin 2 into t minus pi minus sin t minus pi. Because sin 2 into t minus pi gives minus sin 2t and sin t minus pi gives sin t. So, the values of these two terms are same as the value of the above term. Similarly, in the third term also, you can write sin 3t as sin 3 into t minus 2 pi minus sin 2t as sin 2 into t minus 2 pi. So, if we now observe, if we have u of t minus pi here and the corresponding terms also have u of t minus pi. Similarly, we have u of t minus 2 pi here and the corresponding terms are also in terms of t minus 2 pi. So, we expressed f of t in terms of unit step functions. Now, let us find Laplace transform of this. Just apply L on both sides. And first is L of f of t minus a into u of t minus a is 0 here and f of t is sin t. Therefore, if we apply second shift property, first one is e power minus as, that is e power minus 0s into L of f of t is L of sin t. And coming to the second term, L of f of t minus a, this is all f of t minus a into u of t minus a, where a is pi here. Therefore, by second shift property, it is e power minus as, that is e power minus pi s into L of f of t. This is f of t minus a. Therefore, L of f of t means just replacing t minus pi with t. Then we get L of sine 2t minus sine 3t. Similarly, in the second term, we have L of f of t minus 2 pi into u of t minus 2 pi. That is equal to e power minus 2 pi s into L of f of t, means just writing t minus 2 pi as t. That is sine 3t minus sine 2t. And we know the Laplace transform of all these functions. L of sine t is 1 by s square plus 1. L of sine 2t is 2 by s square plus 4. L of sine 3t is 3 by s square plus 9. So that is e power minus 0s into sine t is 1 by s square plus 1. L of sine 2t is 2 by s square plus 4. L of sine t is 1 by s square plus 1 plus e power minus 2 by s into L of sine 3t is 3 by s square plus 9 minus 2 by s square plus 4. Now let us see another problem. Again the similar problem. Express the following function in terms of unit step function and find its Laplace transform. F of t is given as t square in the interval 0 to 2, 4t in the interval 2 to 4, 8 in the interval 4 to infinity. Now let us express f of t in terms of unit step function as f of t is equal to f1 of t, that is t square, into u of t minus 0 minus u of t minus 2 plus f2 of t, that is 4t, into u of t minus 2 minus u of t minus 4 plus f3 of t. f3 of t is 8 into u of t minus 4. Now if we rearrange and combine the terms, we get t square into u of t minus 0. Combining u of t minus 2 terms, we get 4t minus t square into u of t minus 2. Combining u of t minus 4 terms, 8 minus 4t into u of t minus 4. Now in the first term, if you look at first term, we have u of t minus 0, a is 0, and this t can be written as t minus 0 whole square. So there is extremely no problem here. It is of the form f of t minus a into u of t minus a. But when you come to second term and the third term, in the second term you have u of t minus 2, but in place of t we don't have any t minus 2 here. So we need to express this function in terms of t minus 2. Similarly, in the third term we need to express this function in terms of t minus 4. Okay. So for that separately I consider the second term and third term, and after simplification again we'll add them. So consider second term, which is 4t minus t square into u of t minus 2. So to write in terms of t minus 2, whenever there is t, I add and subtract 2. So here I have 4t. I write it as 4 into t minus 2 plus 2. Minus I have t square here. I write it as t minus 2 plus 2 whole square into u of t minus 2. That gives 4 into t minus 2 plus 8 plus expanding this whole square here. See here. Expanding whole square, a plus b whole square. A is t minus 2 and b is 2. A plus b whole square is a square plus 2ab plus b square. So that gives a square plus 2ab plus b square into u of t minus 2. So just simplify that, and that gives 4 minus t minus 2 whole square into u of t minus 2. So this is of the form f of t minus 2. Now consider third term. 8 minus 4t into u of t minus 4. So here also wherever I have t, I add and subtract 4. Therefore 8 minus 4 into t minus 4 plus 4 into u of t minus 4. That is equals to minus 4 into t minus 4 plus 2. So the quotient of u of t minus 4 is written in terms of t minus 4. Now replacing second and third term in the above equation, we get f of t as this. F of t, first term remains same. Second term I replaced with this. Third term I replaced with this. So now apply Laplace transform on both sides. L of f of t gives L of t square into u of t minus 0 plus L of 4 minus t minus 2 whole square into u of t minus 2 minus L of 4 times t minus 4 plus 2 into u of t minus 4. I think there is some mistake here. I need to change this. Please change this like this. Okay. Now let us evaluate the Laplace transform using second shift property, second shift theorem. We can directly apply second shift theorem here because each term is of the form. The first term is of the form f of t minus 0 into u of t minus 0. Second term is of the form f of t minus 2 into u of t minus 2. Third term is of the form f of t minus 4 into u of t minus 4. So directly we apply second shift property. So applying second shift property, that gives e power minus 0s into L of t square plus e power minus 2s into L of 4 minus t square minus e power minus 4s into L of 4 into t plus 2. Now just evaluate the Laplace transform. E power 0s is 1. L of t square is 2 by s cube plus e power minus 2s into L of 4 is 4 by s minus L of t square is 2 factorial by s cube minus 4 into e power minus 4s into L of t is 1 by s square. L of 2 is 2 by s. Just take the LCM and after simplification you get this term. Okay, this is how we can apply unit step function and second shift theorem to evaluate Laplace transform of the functions. Here are some practice questions. Express the following functions in terms of unit step function and hence find its Laplace transform. I gave 3 practice questions for you. With the understanding and experience of solving the above 3 problems, you can easily solve these 3. Okay. In case of any doubts, please contact me. Thank you for watching the video.